that adds up to the pool of conversion factors that we have in the stoichiometric calculations. Previously in chapter 8, we learned how to convert grams of a reactant to grams of a product using a sequence of conversions that uses molar mass to convert grams to moles, mole to mole ratio in the equation to convert moles of the reactant to moles of the product, and then molar mass of the product to convert moles to gram. Equally, we can use molarity to do similar conversions if you're describing a solution reaction. But in this case, the amount of the solution is going to be expressed usually in volume. You will use molarity definition as a conversion factor to convert volume of a solution to number of moles of a reactant, and then still use the mole to mole ratio of the balanced equation to convert moles of the reactant to moles of the product, and then use molarity again to convert moles of the product to volume or molarity of the solution. So molarity is gonna work as a new conversion factor in these types of calculation here. For this reaction right here, reaction between sodium hypochlorite with ammonia to make hydrazine, sodium chloride, and water. So if you mix 750 milliliter of this concentration of hypochlorite with excess ammonia, how many moles of the product hydrazine is expected to form? So we will start with 750 mils, which is the amount of the reactant, and then convert it first to liter, because we have to use liter as a unit for volume in these calculations. So we'll multiply it times 1 liter over 1,000 milliliter, and then use the molarity to find the number of moles of sodium hypochlorite. So we'll multiply it times 0.806 moles sodium hypochlorite over 1 liter. Now we have the moles of sodium hypochlorite. We can convert it to moles of hydrazine using the mole to mole ratio from the balanced equation, which is basically 1:1. So it's going to be 1 mole of sodium hypochlorite produces 1 mole of hydrazine, should give us 0.6045 moles. If you know the final volume of the solution to be 1.25 liter, what would be the molarity of hydrazine? So as we know, molarity equals number of moles divided by volume. So in liter, so it's going to equal 0.6045 moles divided by 1.25 liters. So it's going to equal 0.4836 mole per liter, or molar. So we can effectively use molarity to calculate similar calculations, whether it's a conversion between volumes of reactants to volumes of products, or volumes of reactants to grams of products. So we combine both conversion factors or both types of calculations. For this example right here, if we are reacting calcium hydroxide with 25 mils of 0.1 molar nitric acid, according to this equation, how many grams of calcium hydroxide would be needed? We start with the number of moles of the acid. It's going to be 25 milliliter. First step is converted to liter. So it's going to be 1 liter, 1,000 milliliter. And then multiply times molarity to find out the number of moles of acid that we have in the reaction, which is 0.1 mole nitric acid per 1 liter. Now we have the moles of nitric acid. We can convert them to the corresponding moles of calcium hydroxide using the equation molar ratio. 2 moles is equivalent to 1 mole of the hydroxide. So it's going to be times 2 moles of the nitric acid react with 1 mole of hydroxide, and then we use the molar mass of hydroxide to convert moles hydroxide to grams hydroxide. So 1 mole of calcium hydroxide equals 74.093 grams. So it's gonna equal 0.093 grams of calcium hydroxide. Second way to do this reaction is using the mole to mole ratio, which is calcium hydroxide to nitric acid. Mole ratio equals 1 to 2, which is gonna equal moles of calcium hydroxide to moles of nitric acid, which is basically molarity times volume for nitric acid. So we rearrange this to solve for moles of calcium hydroxide. So moles calcium hydroxide is going to equal molarity times volume for nitric acid divided by 2. So it's going to equal 0.1 molar times 0.025 liter divided by 2. And then we take this number of moles, multiply it times the molar mass to get the grams. So it's going to be grams equals 0.1 molar times 0.025 liter divided by 2 times 74.093 gram per mole. So it's going to give us 0.093 grams.